Good morning, students. Today we are going to discuss Unit 2 Vector Calculus in Mathematical Physics. Vector calculus implies that we are going to differentiate or integrate vectors. And in this unit we are going to cover these topics: vector differentiation, directional derivatives, definitions and physical significance of gradient, divergence, curl, Laplace operators, vector identities, line, surface and volume integrals, statement, proof and simple problems for Gauss divergence theorem, Stokes theorem and Green's theorem. So we are going to cover all the topics under vector calculus. So as I said earlier, vector differentiation and integral. See, vector differentiation and integral, that will come under vector calculus. So vector calculus means we are going to differentiate and integrate any vectors. Okay, then we are going to cover these topics. Vector differentiation. Vector differentiation involves finding the rate of change of a vector or a vector field with respect to the scalar variable. So we are going to differentiate or integrate the vector fields. The derivative of a vector is found by differentiating each component of the vector individually. So there will be three components. For example, when you take 3 dimensions, so we have 3 components I, J, K. So you have I, J, K. So 3 components are there. So we are going to differentiate each component individually. So each component individually with respect to the variable of interest. This concept is crucial for understanding how physical quantities change and is a fundamental to various fields like physics and engineering. Even now it is in computers also it is used, like animation. So we can go for any animation using these vector fields. In computer science also it is used. So in physics, and of course we know about the gravitational fields and electromagnetic theory, it is used in physics. In engineering also, in aerospace, aeronauticals, even in electronics, so that also is used in engineering. The vector differential operator is known as del operator. So this is called del operator. This symbol is called del operator. So del equals I partial d by dx plus j partial d by dy plus k vector partial d by dz. It's a vector quantity. So del operator is a vector quantity. Don't forget, this is very important one. It is used in operations like gradient, divergence and curl. So we are going to study these 3 things: gradient, divergence and curl with this del operator. So del operator is a vector quantity. It is expressed as this. Now del squared is a Laplacian operator. So del dot del will give us del squared. Del dot del will give us del squared. Del squared is a Laplacian operator. It's a scalar quantity because del dot del will give you I partial d by dx plus j partial d by dy plus k partial d by dz dot with the same quantity. I dot I will give you 1. So we have d squared by partial d squared by dx squared. J dot j will give you again 1. K dot k will give you again 1. So we have partial d squared by dz squared. So del squared is expressed as partial d squared by dx squared plus partial d squared by dy squared plus partial d squared by dz squared. It's a scalar quantity. So del is a vector quantity, whereas del squared is a scalar quantity. Some differential operators. So as we discussed about gradient, divergence and curl with del. So gradient is expressed as grad f. F is a scalar field. Grad. So this is called gradient. So abbreviated as grad. So grad f, which is nothing but del f. I repeat, gradient, which is nothing but grad f, which is equal to del f. So it measures the rate and direction of change in scalar field. So scalar multiplication. And the next one is divergence. Divergence means which is coming out or which is going inside. This is called a divergence. So divergence will dive f equals del dot f. So divergence is expressed as del dot f, where f is a vector quantity. Del also is a vector quantity. Vector dot vector will give you scalar. So divergence of vector will give you scalar. Is it okay? So dot product will give you always answer as scalar. A dot b equal to, it's a scalar quantity. So it measures the scalar of a source or a sink at a given point in the vector field. So this is nothing but a dot product. Curl is something like this. You have a rotation or swirling. So that's called a curl. Curl F is del cross F. Div F is nothing but del dot F. Curl F is nothing but del cross F. It measures the tendency to rotate about a point in a vector field in R cube space. So this is called a cross product. So this is a dot product. This is scalar multiplication. These three things we are going to learn. Now let A be a vector depending on parameter u. So A depends on u, then it is defined as, you have a vector A which is equal to component of each A vector is nothing but Ax of u, Ay of u, j plus Az of u of k. The derivative of AU is obtained by differentiating each component individually. See, each component individually. So we are going to differentiate each component individually. See, we are going to differentiate each component individually. This is the derivative. Nth derivative is given by d to the power n a, du to the power n. So this is single derivative. This is nth derivative is given by this. What is the magnitude? Just take the square and take the root. So that's called a modulus. So modulus will give you the magnitude. Magnitude is nothing but modulus of a vector. So which is defined as this. You have to take the square and take the root. That will give you the mod. Mod is nothing but your magnitude. Gradient of a scalar point function. So as we discussed earlier in the table, like grad f is given as del f. So which is nothing but your gradient field. F is nothing but a scalar field. So the gradient of a scalar point function is denoted as grad or del f and is defined as this. What are the properties of gradient? If f and g are two scalar point functions, then grad f plus g equal to, individually you can add grad f plus grad g, which is nothing but del f plus g is equal to del f plus del g. Individually you can add. Then another, if f is any constant, then the scalar function, then it is grad f equal to 0. If it is constant, the grad function will be equal to 0. If f and g are two scalar point functions, then grad f g equal to f grad g plus g grad f. So you have del f g equal to f del g plus g del f. So these are the properties. Normal and unit normal. So this is your unit normal. If f is any scalar point functions, then the normal to the surface f is given by grad f or del f. Grad f or del f, which will give us normal unit vector, unit point. The unit normal is given as del f divided by mod del f. So we are going to discuss some problems using this to find out the unit normal. Del f divided by mod del f. So we will solve one problem. Find the normal to the surface. So this is the equation of a surface. F equals xy plus yz at the point 1, 1, 1. So this is x, this is y, this is z. Okay. So find the normal. What is the formula? Del f divided by mod del f. So first we will find out del f now. So your del f equals I partial df by dx plus j partial df by dy plus k partial df by dz, which is equal to, what is f here? xy plus yz. You will have differentiate with respect to x. See, I df by dx implies that you are going to differentiate with respect to x. When you are going to differentiate this with respect to x will give you, so this will give you y. When you are going to differentiate, answer x is nothing but 1. So you have y. There is no x here, so 0. So the answer will be y alone. So y multiplied by I. Is it okay? Now when you are going to differentiate this f with respect to y. So when you are going to differentiate, this becomes x. This becomes z. So x plus z. So x plus zj. When you are going to differentiate with respect to z, so that will give you, this part will become 0. This part will be y. So yk. So del f is nothing but this. What is the formula? Del f by mod del f. So del f at the point, it's given us at the point 1, 1, 1. Wherever you find x, you have to substitute 1. Wherever you find 1, you have to substitute 1. Wherever you find z, you have to substitute 1. So 1, 1, 1 will give you, so instead of y, you have to substitute 1. So I plus 1 plus 1, that will give you 2. So 2j plus k. So that is nothing but your del f. Now del f divided by mod del f will give you unit normal to the surface. So this is your del f, and del f mod will give you root of, you have to take the square of each component, you have to take the square of each component and the root. So that will give you 1 square plus 2 square plus 1 square. 2 square is nothing but 4, 4 plus 1, 5, 5 plus 1, 6 on root 6. So this is your unit normal to the surface. Very simple problem. Okay. Now calculate the unit normal vector at minus 1, 1, 1 for f is given. So your scalar function is given as this and unit normal is asked. So phi is given as this. So earlier we have taken as this as f. Now this is phi. Both are the same. Both are scalar functions. So f equals 2xy plus xz plus xy. So your del phi, you will differentiate with respect to x individually, then y, then z. You have to add all those things. That is what del. Correct? See, del is nothing but this. So now differentiating this with respect to x. X will give you, any idea? This becomes 0. There is no x here. We will have differentiate. So z. This becomes y. So z plus y. So y plus z. So z plus y times y. I plus, when I want to differentiate with respect to y. So this becomes 2z. This becomes 0. Very good. This becomes x. So 2z plus xj. Is it okay? When I want to differentiate this with respect to z, so this will give you 2y. This becomes 1. Z is nothing. So x. There is no z here. So 0. So 2y plus x times k. Now you will have to substitute for x. You will have to substitute minus 1. You will have to substitute 1 for y. You will have to substitute z for 1. So we have x plus y. So 1 plus 1. 1 plus 1 is nothing but 2y. And 2z is nothing but 2 multiplied by 1 will give you 2. And x is nothing but minus 1. So 2 minus 1 plus 1. And here 2y plus x, you will have to substitute 1 here. So 2 minus 1, that will give you again 1. So 2y plus j plus k. So this is your del f. Mod del f will be root of 2 square plus 1 square plus 1 square. That will give you root of 6. And del f by del phi, mod del phi will give you this. Okay, any doubt? So this is your unit normal vector. Okay. Now we will go for next problem. Find the unit normal vector to the surface is given as this at 1 comma minus 2 comma 1. So the formula is n cap, which is equal to del phi divided by mod del phi. So del phi is given as this expression, and we will have to differentiate this with respect to x, y and z. So when you are going to differentiate this with respect to x, will give you 2x, and this will be y, this will be 0, and this will be yz. So yz plus, times I plus, and this will give you with respect to differentiating with respect to y will give you, this will be 0 and this will be your x, and this will be 2y and this will become xz. So xz times j. The last one we have differentiate with respect to z. So this is 0, 0, 0, xy alone will be there, so xy. Now you have to replace with the points which are given as 1 comma minus 2 1. So 2 multiplied by 1, y is nothing but minus 2, 1 multiplied by minus 2, so that will give you 2 minus 2 minus 2, this 2 and this 2 will go off, and you have 2, so 2y. Correct? Is it so? Is it wrong? 2 minus 2 will give you minus 2, so we have minus 2y. So there's a mistake here, it is minus 2y. Is it okay? This 2 and this 2 will get cancelled. We have minus 2y, so minus 2y. What is this one? Again minus 2j. Now it's correct. 1 plus 1 is 2, so minus 2j, so minus 2j. And here it is minus 2k. So the answer will be minus 2y, minus 2j, minus 2k. What is your del phi? Del phi is you have to take the root, take the square and take the root. So minus 2 whole square will be again 4. Minus 2 whole square 4. Minus 2 whole square 4. 3 4s are 12. Now this can be written as 2 root 3. So your del phi by del phi, it's correct here. Here it is wrong, here it is correct. So minus 2y minus 2j minus 2k divided by 2 root 3. Just pull minus 2 out. So that will give you minus 2i plus j plus k. These 2 and these 2 will get cancelled. You have this minus sign should be out. Okay, this is also wrong, correct? Minus sign should be out. So minus 1. So minus sign should be out. So minus I plus j plus k. Here also it's wrong. Minus I plus j plus k divided by root 3 will be your unit normal to the surface. Any doubt? Simple one. Now vector differentiation. The position of a moving particle at time t is given as x equals 4t plus 3, y plus t square plus 3t, z equals tq plus 5t square. The velocity and acceleration of the particle. We are going to find out the velocity and acceleration of the particle. Position is given. This is nothing but a position. Okay, position or displacement. We are going to differentiate with respect to t, that will give you velocity. You have to differentiate again, that will give us acceleration. So you have to differentiate 2 times. So the magnitude of the both velocity and acceleration at the point t equals 1, we are going to find out. Now the parameter. The parameter t, the position vector is given as, we have to remember this position vector which is equal to r vector which is equal to xi plus yj plus zk. Often it will come in vector calculus. So remember this one. The expression for position vector is given as r vector equal to xi plus yj plus zk. Now, so r of t equals, instead of x you substitute 4t plus 3. 4t plus 3. Instead of y you substitute t square plus 3t. Instead of z you substitute this. So that will give us the position vector together. Okay. Now velocity is defined as rate of change of position. So rate of change of position. We will differentiate with respect to t. So when you are going to differentiate with respect to t, will give you 4 plus 0. So 4i. When you are going to differentiate, that will give you 2t plus 3. So 2t plus 3. When you are going to differentiate this, that will give you 3t square plus 10t. Correct? 10t. Now acceleration is given. Again you have to differentiate. When you are going to differentiate, this answer will be zeros. So there is no t here. 0. Here there is t is here. Say t is here. So answer is 2. So 2j. Here it is 60. So 60. 10. 60 plus 10k. So this is your acceleration. So we have found out now velocity and acceleration of the particle we have found out. Now at t equal to 1, we will have to find out the velocity of the particle. So it is asked velocity and acceleration at the t equal to 1. The expression for velocity is given as this. Correct? At t equal to 1. So wherever you find t, you substitute 1. So you will have 4i plus 2 times 1 plus 3 times j plus 3 1 square plus 10t k. So simplifying, that will give you this. So this is 4i, 2 plus 3 5j, then 3 multiplied by 1 3, here it is 10, so 13. So 4i plus 5j plus 13k at t equal to 1. Then we will have to find out the magnitude. Magnitude of the velocity is given as, take the modulus, that will give you this, root of 5 square plus 5 square plus 13 square, which is root of 16 plus 25 plus 169. So that will be root 210. So this is your modulus of the magnitude of the velocity. At t equal to 1, the acceleration of the particle is given as this expression. See, this is your acceleration. Correct? So acceleration will be d squared r by dt squared at t equal to 1. So this is your acceleration. You substitute for t equal to 1 here, t equal to 1 here. So we have, so 6 multiplied by 1 plus 10k. So we have 2j plus 6 plus 10, that will give you 16k. What is the magnitude of the acceleration? Which is nothing but you have to take the mod squared. So when you are going to take the mod squared, this becomes 2 squared plus 16 squared. So that will give us root of 4 plus 256, root 60. This can be written as 4 multiplied with 65, which is equal to 2 times root of 65.